Experiment 5, power factor and time constant. Part 1, electric energy in AC circuit. We are going to simulate the circuit by using the Tinkercad website. We go to the Tinkercad website and we choose the circuit and we are going to create new circuit. And for part 1, we need backdrop. And we need capacitor, one capacitor and resistor, and we need to rotate this to the position, connecting in series with the capacitor and resistor connecting in series, and we need the power generator. Power generator is oscilloscope. It does give the signal, and we need 3 oscilloscope in order to measure the signal across the source, the capacitor and the resistor. We adjust the power generator to 120 Hz and the peak to peak is 10, offset is 0, and it's going to kill the signal outside. And the value of the capacitor is 4.7 microfarad, and the resistor is 100 ohm. And we connect the positive of the source. And the negative to the negative, we measure the signal across the source. We signal the voltage signal across the source, voltage signal across the capacitor, we connect like this, measure the voltage signal. I put it this way in order to easy to recognize. And I adjust the time per division to be 5 millisecond in order to another oscillator to give the readable signal, and I start simulate. And this is the V peak to peak. V peak to peak the same. The same in like to see this from this V peak to peak and this V peak in order to measure the RMS across the source, the current on the source, the capacitor and the resistor. We need to divide V peak by square root of 2, and we will get the root mean square voltage RMS we stop simulating and we move to the second part, the phase relationship of capacitor, inductor, and power factor in circuit. This time we need capacitor, and we don't need to measure the signal across the source. We only need to measure the signal across capacitor and signal across resistor. This time we need capacitor of 4.5 microfarad, the same, and we need this time resistor of 3.3 kilo ohm. The power generator this time, peak to peak is 10, but the frequency of this case is 1 kilohertz, which means 1000 hertz, and adjust the time to be 500 microseconds in order to give the signal that readable, easy to see. And I start simulate it a little bit slow in its time to simulate this. It will be now, and this is going to give the phase angle of the capacitor and the resistor in the same phase, which means it like the same phase, which means phase equal to 0 between capacitor and resistor. So I'm going to stop simulating. I'm going to have 2 seconds, but this time I connect the capacitor with resistor. Oh, not capacitor, inductor. This time we need inductor. Connected in series with resistor. And need to measure the signal. The wire a little bit meshy, but it look more understandable, easy to read. And we need the value of the inductor, 33 millihenry, and I adjust to be 20 microsecond. We give the readable circuit, and this time the power generator 10 V peak to peak, but this time equal to 10,000 hertz. It means 10 kilohertz. Start simulation. We give the phase angle of the inductor and the resistor in the same phase angle. As we can see, in the same phase angle. We move to the third part of the experiment. So the third part is constant of charge and discharge of capacitor in AC circuit. Stop simulating. This time we need capacitor and resistor. I'm going to delete inductor and I'm going to add in the capacitor. No, wait, we have to connect this first. And this is in power on series and activities. This one is going to measure the signal of the source. We are going to see the charging and discharge. And this time the capacitor is 60 nanofarad and the resistor 3.3 kilo ohm, and I adjust the time per division to 300. I have to show 300 microsecond, and the power generator this time only 500 Hz, and we peak to peak is 5. Start simulation. But this time we don't need the sign, we need the square. We can see this is the signal of source, and this is the signal of the capacitor. This increment is the charging region, and this decrement is the discharging region, and you can count this to find the time per division of the or the time constant of the charging and discharging period of the capacitor. And thank you. This is the end of the simulation. I stop now.